First of all, we're going to talk about modulation of frequency shift keying. This is the circuit diagram. First of all, let's see what are the components required. We're going to need 555 timer, IC 555 timer. Then we need transistor BC548. We need two capacitors, one of 0.1 microfarad and the other is 0.01 microfarad. We need 4.7k resistor. We need 100k resistor, and then we need 2.5k resistor, which I couldn't get directly. So what I've done here is I'm using 2.2k resistor in series with 300 ohm resistor. That will be equivalent to 2.5k resistor. Coming back to the circuit diagram, on the base of the transistor BC548, we are going to put a pulse signal with an amplitude of 18 VPP, 18 voltage peak to peak, and a frequency of 100 Hz. And the output will be taken out from the third pin of the IC. Let's get started. First of all, this is IC 555 timer. I'm going to put it here, and then I'm going to take the transistor from the flat side. Let's collect a base emitter. So let's get the base part done. This is a 100 ohm resistor that we need from the base, from which we're gonna give the input pulse signal to our circuit. For the emitter, I'm making use of my series connection, as I told you before, 2.5k. So this 2.2 resistor is in series with 100 ohm resistor, in series with another 100 ohm resistor, which is again in series with 100 ohm resistor, which finally goes to the 7th pin of the IC, which is the discharge pin. Later, we're gonna short circuit our reset pin, which is pin number 4, and VCC, which is pin number 8, and we're gonna pull up this pins to 5 volts. This is pin number 4. This is pin number 8, which is pulled up to 5 ohms. Later, 6th and 2nd pin are short circuited. Sixth pin and 2nd pin. Then from the 2nd pin to 5th pin, there is a capacitor of 0.1 microfarad. And also from 5th to
input analysis. So we have done the circuit. Now we'll see the input here. As you can see, we've given the signal square wave, 18 amplitude, and frequency is 100 Hz. Here we generate the same signal. We can see that this is x1 and x2. Delta x1 is -10, and when we reciprocate it, it's coming 100 Hz. Now for y1 and y2, we see that delta y is 18 volts. So now we have done this on pen and paper. Now we'll now we've done the circuit. Now we'll do the output analysis after.
Giving the power supply 5 voltage to the 555 timer and as well as the transistor. As we can see, we have this output, so we can just scale. Alright, first of all I'm going to show you the cursor values. As you can see, if I'm taking one cycle of our signal, we are getting delta x is 9.5 milliseconds, and when we're gonna reciprocal it, we are getting the message signals frequency, which is approximately 100 hertz. If I'm gonna shift it slightly, we're gonna get exact 100 hertz, which was a message frequency. One more thing, when we will change the VDD voltage value, so we can observe that this threshold, this value or amplitude in the output signal is changing. When I'm gonna decrease the voltage value from the RPS, when I'm gonna decrease it, the value is gonna fall below this. Now coming to the main part, as we can see, this is the utmost clean signal with the minimum ripples available. Now coming to the circuit diagram again, we need to our main objective of this experiment is to reduce the ripples. This can only be done by adjusting this RC circuit that we have discussed in when we were looking at 555 timer. That's why I have introduced a potentiometer instead of a resistor, so that I can change the values of the resistance and I can show you the changes on the circuit. Coming back to the circuit, when I'm gonna change the upper resistor value, I'm changing the upper resistance value, so we can see the pulse width of the pulse width of the high signal and low signal is varying. So I can adjust my pulse width from this resistor. Again, from the second resistor, I can adjust it's gone. As I have turned this resistor, I have shorted this resistor, so this is the value of the ripples are gone. And when I'm switching it on, the pulse width keeps on increasing, and when I'm gonna increase it, we're gonna get the pulse width as 1, which is the complete cycle, and which is not the signal. Again, when I increase the value of the resistance too much, we can see the number of ripples, it's gone very high. We can see a lot of ripples in our signal. That's why, to show you this effect, I have introduced a potentiometer in it. Now we will be talking about the demodulation of frequency shift keying. This is the circuit diagram, and first of all we're going to talk about the components that we require. This is the op-amp IC754 that we need, and also we need LM565. This is the diode that we need, 0A79, 200K and 4 10K resistors we're gonna need. Apart from that, we need a 10K potentiometer. This is the potentiometer. Potentiometer is just a variable resistor. This is a demodulation circuit in which this is LM565 IC. On pin number 2, we're gonna put our FSK. With FSK, we're gonna take from the function generated directly. First of all, this is LM565. We're gonna connect it here on one side of the breadboard. This is the op-amp which we're gonna attach on the other side of the breadboard. As we can see here, the third pin is connected to ground via 100K resistor, as well as the second pin is also grounded via 100K resistor. Here we have 200K resistors, which I am putting it to ground. Then we can see that 4th and 5th pin are shorted, so I'm taking a wire and I'm shorting these 2 pins. Now we can see that the input from 6th pin is going to the 2nd pin of the op-amp. And then we have a pull-up network. We're going to use these capacitors. power from the 7th pin. So there's main supply. We can see the below line will be our positive 15 volt, and the one section of the upper line will be our negative 15 volts. So as we can see, negative 15 volts is supposed to be given on the first pin of LM565. So I'll take this minus 15 connected to the first pin. Also, the op-amp is supposed to be given minus 15 volt through this line. Op-amp requires positive 15 volt on 7th pin, and the output from the op-amp will be given out by a diode, which is pulled down by 100k 10k resistor. I'm sorry. Here also I'm shorting the above line, and I'm gonna make use of this line, the complete ground for pull-up network. One, two, so I'm creating this connection. It's goes to the capacitor, which is pulled up to plus 15. Now I'm making this connection, and finally it goes to third pin of the op-amp. Finally, we need this 0.01 microfarad capacitor, which will be between first pin and ninth pin of the LM565. So, ninth pin and first pin. Also, we are going to use a potentiometer, which will be between positive 15 and negative 15. And the variable part is the central part, which will give us the variable resistor. It will go to the 8th pin of the IC, and via 10th pin we will give power supply to the IC. The only thing remaining is this capacitor, through which we're gonna give FSK input to the circuit. Now our circuit is completed. Now we have assembled the circuit in the breadboard, and this is a demodulated output that we got. From this demodulated output, I'm gonna stop it for a second, and we're gonna switch on the cursors. This is my X2 axis, which I'm gonna stop it at this point. The another axis is here. As you can see, I'm moving it here. So between X1 and X2, I'm keeping my one cycle of the output, which is, and the difference of it, you can see it here. This is delta X, and 1 by delta X, like 1 by time period, will give us the frequency. That was the message frequency given here, 100 Hertz. And in the output, we're getting the same 100 Hertz here.